In this video, I will explain how to do proofs in the Predicate Logic software. So we're going to, as with other things, we're going to start on the symbolization page. And we're going to check our symbolization first, and then once we've done that, we can go to a proof. So I'm going to do exercise 3 from chapter 3. So exercise 3 says, some deductive arguments are not syllogisms. Proof. Mathematical arguments are all deductive. Some mathematical arguments are not syllogisms. So that proof tells us that what follows after the word proof are our premises, and what comes before it is the conclusion. So we'll start with the premises. So the first premise says mathematical arguments are all deductive. So this is a universal statement. So shift for every x, if x is a mathematical argument, then x is a deductive argument. No. Doesn't like that. Why not? Oh, I'm sorry. My bad. I want to be in supposed to be in chapter 4. That's why. I wanted to do exercise 3 in chapter 4. That's what I was looking at. Okay, let's try that again. So all mathematical arguments are deductive. There we go. Some mathematical arguments are not syllogisms. So there exists an x such that x is a mathematical argument and it's not a deductive argument. No? Oh, it's not a syllogism. Sorry. Right, that makes more sense. Okay, and the conclusion then is some deductive arguments are not syllogisms. So there exists an x such that x is a deductive argument and it is not a syllogism. Okay, so then we click on the 2 proofs and it takes us to a page with our proof all filled in. Okay, so the first thing that you want to do in a predicate logic proof is strip the quantifiers off of everything. So instantiate everything. However, you do need to do it in the right order. So remember, there's a restriction on existential out that says that the letter that you're instantiating has to be new to the proof. So you don't want to do the universal statement first and then do the existential statement, because then you can't use the same letter. So you have to do them in the right order. If you do accidentally do them in the wrong order, you can just instantiate the universal statement again. Or you can just move things around and then things will be fine. But all right, so we're going to do the universal statement first. So I'll use the letter A because why not? Whoops. Okay, so that's 2 and existential out. All right, then we're going to do the universal instantiation. So that's 1. Universal out. Okay, and what we're trying to get to is the statement dA and not SA. We can get to that, then we can get our conclusion by existential in. Okay, so, well, we're going to need DA and we're going to need SA. So we can get not SA, easy peasy, by 3 ampersand out. And getting DA is not very difficult either. We can get it from the antecedent, so the consequent of this conditional, if we have its antecedent MA, and we can get MA anytime we like by 3 ampersand out. So easy peasy. So now we get DA by 4, 8, arrow out. And then we get DA and SA by 9, 5 ampersand in. So Pospesel always likes you to say the line number that corresponds to the left conjunct first and then the right conjunct. I don't care about those details. Okay, and this is going to be 10 existential in. And then we just need to clean things up. Let's get rid of these blank spaces so Pospesel doesn't yell at us and so it doesn't look ugly. And then we can check our proof. Hot dog! So that's all there is to it. It's really not much more to it than the propositional logic proofs. It's really just instantiating, but it works exactly the same way. You've got a couple new buttons to use, which you're already familiar with because of the symbolizations. And other than that, it's exactly the same.